We ended the previous video with this question: why some 2D vectors fill R2 while others don't? The answer lies in the concept of vectors being linearly independent and dependent. Dependent vectors in R2 just overlap like this, and their combinations form a line. Let's look at two vectors in R3. Can they fill the space? Note that these two vectors are linearly independent. If we observe, any linear combination of these vectors will be of the form x1, x2, and 0. This is because the z component always stays 0, no matter how we add or subtract. Let's visualize it, and you can see that the two vectors only make up the plane in R3, specifically the xy plane. As the z component is always 0, there is just no vector present there. This means we need a third vector to our set to fill the space in R3. This set with the least number of vectors needed to fill the space is called the basis. Now what if we add another vector to this set? Well, since the first three vectors can fill the space already, or in other words, can produce any vector in R3, this means the fourth vector can be written as a linear combination of the first three. And using this fourth vector, we can easily fill the space. So this fourth vector in R3 is just redundant. In fact, we can have as many vectors in our set as we want. As long as there are three linearly independent vectors, we can fill the space of R3. Let's look at what a span of these vectors is. It's nothing but just the collection of all possible linear combinations of these vectors. In this case, the span is the entire R3. To relate basis and span together, we'll have a look at this. If the span of some vectors give us that vector space, given that all those vectors are linearly independent, then they are the basis. So to summarize, we need n linearly independent vectors in Rn to be the basis of Rn. Or we can say to span a space Rn, we need n linearly independent vectors, no more, no less. This is why we need 3 linearly independent vectors to span R3, 2 for R2, and so on. But what exactly makes up a vector space a vector space? There are two main properties of vector spaces. They must be closed under vector addition and scalar multiplication. What does that even mean? First, consider two vectors being added. If the resultant vector also lies in the same space, we call it to be closed under vector addition. Suppose we want to check if the first and second quadrants of this plane makes up a vector space or not. Let's take a vector from the second quadrant and 3, 8 from the first. What do we get on subtracting the two? We get -7, -6, which lies in the third quadrant, which is not part of the vector space we began with. So the first two quadrants do not form a vector space. Now let's look at scalar multiplication. This too means more or less the same. When multiplying a vector by a scalar number, it must stay in the same space. This time let's see if the first quadrant makes up a vector space. We'll take a vector 3, 8 and multiply it by -1. As -1 is a scalar, it gives -3, -8, which again lies in the third quadrant. Therefore, first quadrant is not a vector space. To dive a little deeper into the definition of a vector space, there are some axioms that it must follow, which are, they might look intimidating, but don't worry, they're easy to wrap your head around. We've already seen the first two. The third one is the associativity property, which says that grouping doesn't matter when adding. The fourth is the commutative, which means the order in which we add them doesn't matter. The sixth says that there exists an additive inverse. Seventh and eighth is about distributivity of scalars over vectors. Ninth means that multiplying two scalars first and then by a vector is same as first multiplying the scalar and the vector and then by the scalar. Last one just says a vector doesn't change when multiplied by 1. So in the next video, we'll dive into some practice questions to solidify our understanding of vector spaces. Let's start with this question. Does this form a vector space where the product of two components is greater than or equal to 0? Leave a like if you found this video informative.